So we're gonna go over some Kubernetes concepts. So just services basically, maybe some later on in other videos about services. I'm just on the first page. I'm gonna read the documentation, do some explainings and some demonstrations. So the Kubernetes network model. Each pod in a cluster gets its own unique cluster-wide IP address. A pod has its own private network namespace, which is shared by all of the containers within the pod. Processes running in different containers in the same pod can communicate with each other over localhost. So processes running in different containers in the same pod. So okay, I'm just putting some accent on this. I'm going to explain it. So here I have a Kubernetes cluster, mini Q status, quick. Okay. Node 3 running, node 2 running, control plane node running. Perfect. Whoop, my bad. Okay, get pods or wide. I have two pods coming from two different deployments. These pods have two different IP addresses, see, 1.2 and 2.2, but they're running on two different nodes, node number 02 and node number 03. If I go take a look on the Kubernetes architecture, so over here, so basically what I read before says we have pods that get IP addresses, and every process, every container that's actually inside these pods get share the same IP address. So that means pod number 1 has a unique IP address. Pod number 2 has a unique IP address. 3, same, 4, same. Okay. So all the containers inside my pod number 1 have the same IP addresses. All the containers inside my pod number 2 share the same IP addresses. It's the same, okay? But pod number 1 has a different IP address from pod number 2. They need to have different IP addresses. Okay, why is that? Okay, why is it so? So, well, see, I can show you the different deployments I created. So, YAML here. So this is the first deployment, right? The only difference here is my dep, right? My deployment is supposed to have 3 replicas, but I just basically scaled it down just before, so that's why it only has 1 pod running. And the image is engine, so that's why it's still running, and that's it. There is nothing complicated about this YAML spec. So if I get to my dep number 2, so my second deployment, right? Well, it's the same. I just changed the label app name, right? That's it. And then the name. Okay, perfect. So what happens when I list my namespaces, right? Because we're talking about in the documentation here, over here, a pod has its own private network namespace, okay, which is shared by all of the containers. Okay, it's the same pod. Okay, so if I list my namespaces, oh wait, a little too much. Let's list only LSNS, grep, let's do nginx. There we go. So let's clear it out. Okay, so I list my different namespaces. So here we have two different. We have two. How can I put this? A set of namespaces for my two running nginx processes / containers, right? So if I list my processes, so here I say UX, grep, nginx. Okay, so here we have a nginx process, so root. This is the PID of my process, 10003, and here we have our second one, right? You can see that the PID matches, right? 10003 here also. So this PID has 3 namespaces, right? A mount namespace, a UTS namespace, and a PID namespace applied to it, right? So the 11977 also has 3 of them, right? But we don't see any network namespace, okay? So that's why actually pods in Kubernetes need to have a different IP address, because they are not namespaced inside the network basically. So if I yeah, so if I look at the Linux manual of namespaces, what we can see here, a namespace wraps a global system resource in an abstraction that makes it appear to the processes within the namespace that they have their own isolated instance of a global resource. So that means if you apply a namespace to a set of processes, right, or process basically, that means this process can only see this much inside your Linux machine, right? So you can apply isolation by cgroups, IPC, network, mount, PID, time, user, UTS. And so if you apply a cgroup namespace, it's going to isolate your process from others on the cgroup root directory level, right? If you do it on the network, it's going to isolate your process on the networking level of your machine. So we could see that when I was doing LSNS web engines, you could see that we have a mount one, so file system one, UTS one, PID one, process IDs one, namespaces applied to my to my two containers, but we have no network namespace, so that's why they can't have like the same IP address. My two pods can't have the same IP address, can share the same IP address, because otherwise when a request comes in, you don't know what pod to reach. That's it. Also, okay, now we saw namespaces in the manual of namespaces. We are talking about cgroups too, right? And I'm going to just show you what it is just for reference. So if I open the manual of cgroups, well, we have here the description. So control groups, usually referred as cgroups, are Linux kernel feature which allow processes to be organized into hierarchical groups whose usage of various types of resources can then be limited and monitored. So basically that means it's an isolation on kernel resources. So if I create a C group that says every process inside that namespace can only use 50% of my CPU, while every namespaced container, right, every namespaced process with that namespace is going to be able to only use 50% of my CPU. So yeah, that's it. Okay, and just before finishing, I want to say, clarify some little misconceptions, right? So don't put the kube proxy or the kubelet or whatever on the same level as pods and services and everything, because a lot of these objects are actually, some of them are abstractions, some of them are like controllers, some of them have like literally running processes in the background, so some of them are just configuration. So is a pod and a service. These things doesn't actually run on your machine actually. You have a kube proxy that does run actually, and this guy is actually going to manage all that configuration about networking inside your node. And that's basically it. All the service configuration, all the endpoint slice configuration, ingress, and yeah, not pods, but everything related to network is going to be managed by the kube proxy. And the pod definition is also just configuration. A pod just means a set of nodes. That's it. And we say a pod or we abstract it by using a word, pod, or by using the word service, right? To say like, we have a group or a bunch of different things, right? Like for pod, in that case, is like a bunch of different processes, so containers, right? And we want to apply some rules to all the instances that runs inside, like all the same instances, of our processes, right? Or you can call it just containers, it's the same thing. And we have like, imagine we have like two containers, right? And we want to apply the same rules to these two containers. So we're going to call that a pod. That's it. It's a set of containers which has rules applied to it. And a service is basically a set of networking rules, and we have a lot of different things, a lot of different abstractions inside a service. They call it abstraction, but it's just a lot of different config files, which will define the behavior of how the requests will be handled inside our cluster. That's it. I don't remember if I showed it, but yeah, in the Kubernetes documentation about services over here, it says all pods can communicate with all other pods, whether they are on the same node or on different nodes. So the Github repository says in the pod util.go file, we can see here the find pod function. And what does it do? Basically, it just does a for loop against all the containers inside our cluster. That's it. See, if port name is the same as name, and port protocol is the same as service protocol, so service protocol will be, see, we can see it somewhere. Service port, this one, service port we actually pass, then return container port. That's it, as in. So basically, we are returning we will be returning on your on your CLI, like here interface, right? You will see the pod, right? The IP of the pod that is returned, right? Remember when I do get pods worldwide, here you have different IPs. Here it's a little sliced. Okay, here we go. Here you have different IPs, and when this pod discovers this pod, it's just gonna say, oh, I found this pod, but actually what it has done is that it has found the container that actually contains that actually has this IP, and then Kubernetes is going to tell you, oh, I found this container, so I'll show you the pod specification where this container lives, basically. You can put it like this.